So the first hybrid file system that we'll talk about is the Hadoop file system. Hadoop is actually a suite of tools. HDFS, which is the Hadoop file system, Yarn, MapReduce, and some common utilities. It's open source via the Apache license, and it has numerous commercial vendors. If you just Google Hadoop, you'll see a lot of them out there, a lot of support that's available. Companies like Cloudera, IBM, Hortonworks, Microsoft, and the list goes on. What's unique about the Hadoop architecture is they originally, abandoned the POSIX compliance. And you can put Fuse on the front of this to give it some of those semantics, but it was not originally designed to be a traditional distributed file system. There were specific algorithms such as MapReduce that were set up to help leverage the architecture. And so let's talk a little bit about that architecture. Similar to when we talked about distributed file systems such as Lustre, there are metadata and storage servers. In this regards, clients can run on the storage servers, which you typically would not see in a file system such as Lustre. Sometimes this is done such that you get the clients as close as possible to the data, so you can co-locate clients on the same server as the data, and this will significantly, hopefully, reduce some of the I/O latency over the network, over distance. You do a lot of file replication in Hadoop, so this is kind of one of the hallmarks. And whether that's file or under the hood, a file can be broken into various blocks. So you're actually going to be replicating the blocks across the Hadoop cluster. So for really large files, you can actually even get to pieces and parts of those files via different blocks spread across the Hadoop cluster. It's also very fault tolerant. By that replication, you can have failure of various servers, and these are commodity servers. Because it's fault tolerant, because there's a lot of replicas, you can utilize more common commodity hardware without having specialized hardware. And this, hopefully, price and performance wise, allows you to scale a little bit better. It's important here to also understand that the clients have direct access to the data nodes. As we talked about, the clients sometimes can run on the data nodes. So it really lowers that proximity and helps, hopefully speeds things up. And related to this is also the Spark file system. When you think about Spark, it has a number of similarities, and you think about, instead of just keeping the data and the processing co-located between a disk storage, Spark takes it to another level and thinks about data location and RAM and some other accelerative properties so that you can really get computation and data co-located as close as possible. Now, some of the drawbacks with that, again, without the POSIX capabilities, your applications don't out of the box simply go to files in a file path, and you cannot necessarily have the same security primitives, the same open, close, sharing, read, write behavior that you would get out of a POSIX compliance file system. However, if you can leverage the MapReduce algorithms effectively, you can really find some significant speed up when you're doing data processing in a Hadoop cluster.